So let's begin with an extremely important chapter in your syllabus called as materials, classified as metals and non-metals. One must understand that in our day-to-day life, there are several substances, there are several elements that surround us. And within this particular chapter, we are going to classify all of these substances into a total of 3 broad categories. The first one is going to be a metal. And here we have extremely good examples such as gold, which is given by the formula Au, and silver, which is given by the formula Ag. If metals are your first category, non-metals happen to be your second category. Here we have the example of carbon, which is an excellent non-metal that you must have seen in the form of coal. Coal is considered to be another physical form of carbon. It's considered to be another allotrope of carbon. Apart from that, I have the yellow colored powder called as sulfur, which is also classified as a non-metal. And if metals and non-metals are your first and second category respectively, the third and the final one is going to be the presence of a metalloid. And here, silicon happens to be a perfect example for the same. Moving on, within this same module, let's discuss a topic called as the occurrence of metals. Now, one must understand that we have a series which is based on the reactivity of metals. It's called as the activity series. It is based in a manner that the most reactive metals are present at the top, and as and when we go into the downward direction, the reactivity keeps on decreasing, which is why the least reactive metals are present at the bottom. If I have metals which are present in the lower portion of the activity series, such as gold, such as platinum, these are the kinds of metals which are very, very less reactive. In fact, they are the least reactive kind of metals. These are the kinds of metals which are found in nature in the free state. So gold and platinum are found in nature in the free state because they are considered to be the least reactive. But if we go upwards in the activity series, the reactivity associated with the metals keeps on increasing, which is why they never occur in the free state in nature. They always occur in the combined state, which means they occur in combination with some other element, with some other radical. You will never have the presence of sodium in nature by the metal sodium itself in the free state. In all probability, its salts are formed, and its salts are found, such as sodium chloride, which is then given by the formula NaCl. So effectively saying, metals occur into a total of 2 states. The first one is the free state, which is valid for the relatively least reactive metals such as gold and platinum. And then we have the combined state, which is valid for the relatively more reactive metals. However, when you talk about the occurrence of non-metals, we have an altogether different story waiting for you. For example, we can say that non-metals are actually some of the most abundant elements which are present in the universe. We have non-metals such as nitrogen and oxygen, which make up most of the Earth's atmosphere. Nitrogen's concentration is around 78% and oxygen's concentration is around 21%. Apart from metals and non-metals, we have the presence of metalloids. And as far as metalloids are concerned, we must understand that these are the kinds of elements which have some properties of metals and some properties of non-metals. Now that effectively means metalloids are present somewhere in the middle. If a metal is towards the left and a non-metal is towards the right, the metalloid's properties will be somewhere in the middle. For example, one must understand that we will study in this particular module that metals are extremely good conductors of electricity and non-metals are extremely bad conductors of electricity. Metalloids will have a conduction of electricity which is less than metals, but definitely still more than non-metals. In a similar fact, one must understand that silicon is actually the most abundant metalloid which is already present in the Earth's crust. Within the same module, let's discuss a relatively important part called as the physical properties of a metal. Now, the first one is called as luster. The word luster over here means shine, and metals obviously have a shiny appearance. So if a metal is manufactured or if a metal is freshly cut, it is going to have a metallic shine associated with its surface. That metallic shine has a special name in chemistry. It's called as metallic luster, which means metals are considered to have a shiny appearance. Because of the same, such kinds of metals which show a metallic luster are used in jewelry, and they're also used for decoration purposes. And we have perfect images for that appearing onto your screen right now. Apart from being lustrous, metals are also considered to be malleable, which means they show the property of malleability, wherein it is understood that if you are going to take a metal and you're going to hammer it down or you're going to beat it down, it's not going to break, it's not going to fracture, it will simply transform itself into a beautifully thin sheet. Now that effectively means that malleability is the property associated with a metal by virtue of which it can be beaten down into thin sheets. So that's exactly what we're going to write down. Metals can be beaten, they can be hammered into thin sheets, which means you can have extremely thin sheets of elements such as gold, aluminium, zinc, and even copper for that matter, because all of them are considered to be metals, all of them are considered to be malleable. And this kind of a sheet is obtained by hammering it down, by beating it down. If a particular material is malleable, it's also considered to be ductile, which means if you take a piece of a metal and you stretch it, it is not going to break, it is not going to fracture, it will transform itself into a beautifully thin wire. Metals are considered to be malleable and ductile. So this is basically the property of a metal by virtue of which it can be drawn into wires. The property is called as ductility, and therefore metals are considered to be ductile in nature. An excellent example for that is the copper wire. Now the thing is, one question that we actually ask ourselves is, how ductile are metals? They are so ductile that gold is considered to be the most ductile metal, and it is so ductile that a single gram of gold can be stretched to a wire which is over 2 kilometers long. So about 1 gram of gold can be transformed, can be drawn into a thin wire which is approximately 2 kilometers long. After that, we have the property of a metal where it is considered to be sonorous. If you are going to take a metal and you're going to bang it against a surface, if you're going to strike it hard, it is going to produce a ringing sound. It is going to produce a loud resonant sound. So things which are made up of metals are considered to be sonorous. They are going to produce a ringing sound when they are struck hard. That is the property associated with school bells and temple bells, and that is the property of a metal being sonorous in nature. After that, one must understand that metals are considered to be extremely good conductors of electricity. Electrical wires are obviously used in our homes, and these are the kinds of wires which are made up of aluminium and copper. They are considered to be good conductors of electricity. They allow a large amount of electricity to pass through them, which is why copper wires are generally used in electrical appliances and even in household wirings. Moving on, one must understand that if metals are considered to be good conductors of electricity, and if wires are made up of metals such as aluminium and copper, they are ultimately protected with an insulator which is not going to conduct electricity, so that you and I, while handling wires, are not going to get electrocuted. Silver, at the end of the day, is considered to be the best conductor of electricity, followed by copper, and that is why electrical wires are made up of copper or aluminium. Metals are also considered to be extremely hard. The only two exceptions to this is sodium and potassium. So metals at room temperature exist as hard solids. However, sodium and potassium metals are so soft that they can be easily cut with a knife, which is something which is available onto your screen right now. Some metals like sodium and potassium are soft, and that is why they can be easily cut with a knife. Metals are also considered to be solids at room temperature. That's very, very obvious. Mercury is the exception to this rule, which is considered to be a liquid metal. So most of the metals are considered to be solids at room temperature. The one that actually breaks the mold is mercury. Because it's an exception, it is going to remain into the liquid state at room temperature. However, moving on, I can also say that we have the physical properties of non-metals into consideration next. Non-metals are various in nature, such as carbon, sulfur, and iodine for that matter, but they are considered to be non-lustrous, which means they are not going to have a metallic shine associated with them. They are not going to be lustrous, which is why non-metals are classified as dull. At the same time, they are very, very brittle. When you are going to hammer them down, they are going to break, they are going to fracture, they will transform themselves into a powder. So the property of malleability and ductility is actually out of question, which is why I can also say that non-metals are not going to conduct good amounts of heat and electricity. They are bad conductors of heat and electricity. While we have an element such as iron onto the left, which allows the electric current to pass through it and therefore the bulb glows, we have the presence of sulfur onto the right, which does not allow current to pass through it and therefore the bulb does not glow. The only exception to this rule is graphite, which is considered to be a form of carbon, and that is the only non-metal which actually conducts electricity. Non-metals can occur in all three states in nature: solids, liquids, or even gases. In the gaseous state, we have non-metals such as oxygen and hydrogen. In the solid state, we have carbon and sulfur. And finally, in the liquid state, we are going to have the non-metal called as bromine. Non-metals have a comparatively low melting point and boiling point. Melting point is the point or the temperature at which a substance converts from a solid to a liquid, and boiling point is the temperature at which a liquid converts into a gas. For a non-metal, the melting point and the boiling point is going to be quite low in nature. The only exception to that rule over here is diamond, which is again an allotrope of carbon. It is the only non-metal having a high boiling point and a high melting point as well. As far as sulfur is considered, its melting point is only 115 degrees Celsius. Now believe me, it's quite low. And that's okay because sulfur at the end of the day is a non-metal. Its melting point is only 115 degrees Celsius. However, if you move on to the opposite end of the spectrum, if you want to look at an exception, we have the presence of diamond. Now diamonds over here have a high melting point at an approximate temperature of 3500 degrees Celsius. The end of the module basically tell you that non-metals are obviously not as strong as metals. However, diamond again is an exception to this particular rule. It is considered to be the hardest known natural substance. Finally, let us understand that non-metals are non-sonorous. When you strike them, they are not going to produce a loud resonant sound, they are not going to produce a ringing sound. And that itself brings me to the end of the first module of this particular chapter.